In this lab, we will introduce you to two different image types. The first, Digital Imaging and Communication in Medicine, or DICOM, is an international standard for medical imaging. It contains a wide array of information that are stored as objects. The image is made up of two components, one being the header, which contains the attributes such as name, ID, sex, imaging parameters used to acquire the data, and others, and then the image data, which is simply a big 3D matrix of numbers. There are many different DICOM image readers available, namely Osirix, which is for Mac only, Radiant, which is a Windows-only viewer, and the ImageJ viewer, which is available across multiple platforms. DICOM images are extremely flexible. However, the majority of neuroimaging analysis packages do not directly use DICOM images when analyzing data. However, sometimes it can be useful to read the header of a DICOM image. The command DICOM_HDR allows you to print the header of a DICOM image inside the terminal. We've already acquired MRI data from 5 different subjects, which you've now downloaded from the course box drive. Use the command DICOM_HDR to print the header of a DICOM image inside the terminal. To use this command, you simply type DICOM_HDR and then provide a path to a DICOM image. For example, an example of this command is seen here. The NIFTI image format, or the Neuroimaging Informatics Technology Initiative, is another standardized image format that is commonly used by different neuroimaging softwares and packages. It provides many advantages and was developed at the NIH. The majority, if not all, of analysis packages for neuroimaging analysis use NIFTI images to some degree. It is very convenient to work with NIFTI images. However, this requires us to convert, as the images that we acquire from our MRI scanner are stored in a DICOM format, it is necessary to convert our DICOM images to a NIFTI format. There are many different DICOM NIFTI converters available, as seen here. We're going to work with a commonly used one called DCM to NIIX. First, to use this, we will need to install DCM to NIIX on our virtual machines. To do so, follow the following commands in your terminal. After installing DCM to NIIX, type DCM to NIIX into the terminal and see what happens. You should see a printout of the description of DCM to NIIX, as well as a long list of available options and flags that can be used. The basic usage of DCM to NIIX is to convert a DICOM image or a set of DICOM images to a single NIFTI image. The following command provides an example of the basis of how to call DCM to NIIX to do this. Convert the DICOM image data to a NIFTI image and save the resulting NIFTI image inside your Lab3 study directory. First, make a subdirectory for the first test subject, for example, test_subject1, in your Lab3 directory, using the following commands and examples provided here. Then use DCM to NIIX to create the NIFTI image, saving the NIFTI image inside this new directory you just created. For example, you could use a similar command as seen here. Now, to open this NIFTI image, we could use FSL's image viewer called FSL Eyes in the following way. FSL Eyes, and then give the path to the NIFTI image that you are created. At the top of the toolbar of FSL Eyes, please set the min to -120 and the max to 1300. Take a screenshot of this figure to include in the results section of your lab report. We will use these NIFTI images throughout the remainder of this lab. As we just seen, we are able to view NIFTI images using viewers available through the various neuroimaging packages that we will use. FSL has two applications for this. One, the one you just used, FSL Eyes, which is a newer viewer that was recently released by FSL, and FSL View, which was the original FSL viewer. To open and use this viewer, you'll have to try it. You can use the following command, FSLView_deprecated. We will plan to use FSL Eyes to view the majority of our images in this lab. However, if you have problems with this viewer, you can also use FSL View by replacing FSL Eyes with FSLView_deprecated. To open an image, you can simply type FSL Eyes followed by the path of the image you wish to open. For example, the following command provides an example of this. If the FSL Eyes command does not open an image for you, please let us know. In the remainder of this lab, we will focus on how to use FSL for performing basic steps in neuroimaging analysis and what each step is doing and why it is done. For example, after acquiring structural MRI data, the basic steps for analyzing this data could be performing a bias field correction, removing the skull or brain extraction, image registration, segmentation, and then performing statistical analysis. This lab will explain each of these steps and walk you through a simple example.